I'm steadily progressing then down the automation route. Kind of everything I'm doing at the minute is geared towards it, whether it's ironing out track issues, or software bugs, or trying to work out how all this automation stuff works in JMRI. Something that I've really focused on as well, now I'm getting more and more trains working and automated, is preparing locos for automation, doing things to them, minor things, configuration, whatever it is, that will mean more reliable running and compatible running with automation once they get automated and running. One particular aspect of that as well is to make, I guess, quite tough decisions on trains and locos, and to thin everything down to stuff that will run reliably and will not stall and cause issues. And to that end, I guess it's a sad moment, but this train, it's kind of in a few pieces because I've butchered a few of its wheels for Resistive wheelsets, but this is the last Ringfield era train. I say train because it's got a consist partner that's got a motor up there as well, but it's the last Ringfield era set of locos on the layout, and it's about to come off. So I mean, really, I've made quite good progress in that. Even when I started, the last layout was very much trains of this era because that's what I started with, and that's what I kind of was intended to run. But as I moved more towards automation on this one, I've kind of had to make those tough decisions and I guess shop around a little bit as well and try and replace the unreliable stuff with more reliable stuff. So this is the last Ringfield one, so it's bit of an end of an era really, and it's about to be taken out of service, I guess. There have been a few other decommissions and replacements over time. That Swallow Class 43 right at the back there, that's now a one of the railroad ones. It's not particularly impressive, if I'm honest. I was a bit disappointed with it, but it does have more pickups and it does have a smoother motor. So it is a semi-upgrade on the old Ringfield one. I have to say it has a lot of drawbacks. The LEDs in the front are just LEDs. They're not on a switch. They're not decoder controls. They're just on and white. It's more like blue. It's such a cool white all the time. The dummy at the other end has nothing in it. No lights, no motor, obviously, or anything like that. It's not particularly strong. It's just got that motor on the back axle, and it struggles to pull the 6 coaches and dummy that it's pulling. So it has been something of a disappointment, and it's the most liable to get kicked off the layout next, even though it's one of the newest ones on. That's a Helgen Class 47 that I did have on the last layout actually, and it's one of the, I think only 2 locos came onto this layout that were actually factory DCC ready, and that was one of them. I've got an old Deltic by Lima that I had as a kid, but that's gone in a box now, and that one down there is a Bachmann one I kind of bought when Acura scale was the big thing, and there were a few Bachmanns falling out the back end on eBay, so I picked that one up reasonably well. Class 101 is the other factory DCC ready train I had on the previous layout and came into this one. Obviously that 43 there is the one that's going. I did in the end replace the blue and grey Class 43 with a newer Hornby one. That one is actually new. I bought that maybe last month or something like that. It's the LNER I don't know, Last Journey one or something like that, but it was good, again, going for a reasonable amount. The Class 91 is new, at least the Class 91 is. I haven't replaced any coaches yet, just because coaches are very expensive these days. So the loco on the front of that Class 91 train is new, but it's got all old Hornby Mark IVs and an old DVT on the end, which are, those Mark IVs are particularly prone to derailments. There's then what's on here. This is just the Super Sprinter. Now this Super Sprinter is almost identical to the Lima one I had, but this is again another railroad range, and it was pretty much a straight swap. I think I got that off eBay new for maybe 50 quid and sold the old one for 40. Again, just better pickups, a more modern, if not certainly not high standard motor, but it runs reliably, and for a little 2-car thing that's fine. I had to put a resistor wheel set in the back of it. The APT is obviously relatively new, and this thing runs quite well actually. This is the more modern twin pacer that has no motor in the back, but has pickups, and then the pickups kind of carry through the connector there and into the motor. I had to. It didn't come DCC ready. I had to modify it, but it does run really quite reliably, so I've hung on to that one. And really, that's everything. Oh, there's a 3-car class 158 down at the back there. Again, that's very old model, and I did have to modify that to DCC myself. It's got a good motor in it, but unfortunately there are problems on the axles on the motor cars in the middle, and the 2 end cars both have problems on the axles, which means I can't put pickups or resistors on the wheel sets, so that might be the next to go, unfortunately. All the way through the storage line I have a lot of infrared sensors that work pretty well most of the time, but they need to work reliably with automation, because they tell JMRI that the train is in the start block that it's starting in, but also they tell JMRI when the journey's finished, when the train comes back into the yard and covers its front sensor, or whichever sensor it's meant to cover. That tells JMRI that the journey's finished, the train should stop and the transit should finish. So just to add a little bit more reliability to this, I've put I have some aluminium tape left from that, and so I've just started cutting little shreds of it and putting it all across the bottom of any loco. Now this loco belongs on this track and covers this sensor here, so I know that really the speed it'll be travelling when it comes back into park is going to be very slow. So this much is enough, because this much is going to have reflected on the sensor. The message is going to have gone back to JMRI, and JMRI is going to have stopped the train before this bit passes. So that stops it over the sensor. First of all, the sensor picks up the foil at the front and stops it, but by the time the train's stopped, this bit might be over the sensor, but at least then it stays occupied and it still knows. And that's been particularly useful if I just lean down a bit underneath the boards, because the sensors were reflecting, because there's not much distance. If there was a sensor there, for example, it was reflecting off the shiny top of the plywood. So with the foil on the bottom of the locos that go under there, I've been able to reduce the sensitivity of the sensors so that they don't bounce off the wood, but they still bounce off this foil when it parks over. And obviously I know where the sensors are, and every train has its own set parking space, so I don't have to cover all of them in foil. I do need them, say on maybe every 3rd coach or something, to cover the sensors that detect whether a long train's in there, but I'm only focusing on putting foil in the places where the trains will be parked over sensors, because there really doesn't need to be anywhere else. Then of course we have resistive wheel sets, and I explained, I think, in a previous video that I put up, why it's important to have resistive wheel sets, not just on the end of a train but all the way through. Once turnouts are turned, blocks become shorter, trains moving slowly, and all that kind of thing. There are good guides out there on how to do this, and really I've just followed them. A couple of the lessons I've learned is use as little super glue as possible, because you don't want the super glue to seep from underneath. They're tiny little resistors, so you don't excuse me, you don't want super glue to seep from underneath the resistor onto the top of it and over the little connector plates, because super glue isn't conductive, and it will obviously block the glue from the electric paint from doing its thing. So I use it as little as possible, and the electric paint really will hold the resistor in once it's done. I've really struggled with the type of, or the strength of resistor. A lot of the guides on the block occupancy systems that I use said 10 10k resistors, but that the half of the block detectors picked them up, but the other half didn't. So I went down to 5.1k, and a lot of those were really burning up after a while and frying basically, and trying to melt plastic on the coaches and all kinds of things. So I'm currently on 5.6. What I'd say is I didn't really have many resistors, and I should have just bought a set of resistors. With hindsight, what I should have done is just tried 7.5s, tried 8.2 and 6.2 and whatever values there were between 5 and 10, and just bought full-size resistors, sat them across the rails for 5 minutes, and made sure that first of all that the block detector actually picked them up, and second that they didn't fry, and then bought a set of little ones. But I've kind of been, I mean they're not expensive, but I've been kind of jumping between different sets of little ones. It's not the end of the world if the resistor does fry, or if the block doesn't pick it up. I just stick the wheel sets in a little tub of water for maybe half an hour, and all the paint comes off, and then you just pick the resistor off and do it again. So nothing's getting permanently damaged or anything. It's just costing me a bit of time to find the right resistor value for this particular layout. There are also little bits of CV configuration that I've been doing just to make the trains run, I guess, kind of how JMRI expects them to. So I've now got my programming track wired up into that new motorboard. So I'll go through a few of the CVs that are set on this loco. Over here in the roster then, I think I've said before how much I like JMRI's roster and CV decoder programming. I've never really, because I've only ever used JMRI, I've never had to worry about CVs and that kind of thing. It's just an interface that really helps me. So with that class 40 on the programming track, I can click this identify. It'll have a little chatter to the loco, and eventually here it'll tell me which loco it is that's on the programming track. So I'm going to program this one. And the tab I'm interested in is the motor tab. So first thing I'm going to do is I'm going to read the full sheet, because I want to know what the settings currently are on the decoder. So this will ask the decoder what its current settings are for all of these values. So go through there, and it never reads this 133 CV. I think it just that CV doesn't exist on the decoder, so it doesn't say anything. Now there's a couple of things here that I'm going to change. First of all, back EMF. Now my understanding of back EMF is it does its best to maintain a constant speed on the loco, because a loco, say you put it at speed step 10 and the decoder decides that needs 5 volts and sets it off. That's fine when it's running in a straight line flat, but my layout has a few curves that are tighter than I'd like them to be. It has a couple of hills, it has an incline. So dragging a few coaches on its 5 volts, whatever it is, once it hits a hill or it hits a tight corner, it's going to slow down because it needs more power to pull and maintain the speed. And again, this is my understanding, I might be wrong. Back EMF does its best to kind of maintain a constant speed by increasing the voltage when the loco needs it. So for that reason, and it might be complete rubbish, I'm going to set that to enabled. And also because once these trains are automated, the JMRI will take care of smooth starting and stopping. It can do that best if the acceleration and deceleration rates are 0. So I'm going to set both of those now. So with those 3 settings set, I can say write changes on sheet. There we go. It had a little chatter again. It's trying to write that 133 CV again that isn't on the decoder, so it isn't acknowledged from that. But that's the decoder programmed. Something that's been noticeable with the trains running on automation so far is they start up. You set a ramp speed for its start, and it really does obey that now, and it does a lovely smooth, slow, progressive start. But stopping, by default, they just stop dead when they need to, and in order to start implementing smoother stopping distances and speeds, there are a couple of things I needed to do. First of all, I had to measure the length of every block and enter that in against the block in JMRI. So I've been running around with a tape measure, and a bit of wire where it went round curves, and I've got the block length set in JMRI now. And the second thing I had to do was speed profile all of the locos, and I think this is so that the JMRI then knows how fast a particular train is travelling at a given speed step, so that it can then work out how long it would take for it to stop the train and stop it smoothly. So the process of speed profiling has actually been really interesting. It's pretty much a case of you choose 3 blocks. The first block is your start block, the third block is your end block, and the middle block is your measuring block. And JMRI has this process of speed profiling where it controls the train, and you just then set it off. And obviously the blocks have detectors, they have sensors on them. So JMRI just continually drives this train up and down at different speed steps between the 3 blocks, and it times at the different speed steps how long it takes the train to cover the timing block, which is actually, to start with, really quite an interesting thing to observe. I'm going to speed profile the Super Sprinter then. And the way it's configured, there are 3 blocks. They're actually sensors really that are selected here. So the start sensor is the block that the train will start in, finish sensor is the block that the train will finish in, and the actual block sensor is the one that it passes through, that it actually profiles the speed on. And I've got a value here in millimeters of the length of that middle block. So I've got my train selected here. I'm going to go in, I'm going to start at speed step 10, because there's not really much point in going below that. It did start, when I first started doing this, it defaulted to speed step 1, which was painful. And we go up to 80 because it's a pretty slow train. In fact, yeah, I'll leave it on 80, and we go up in steps of 5. So that's all done. Let's start profiling. And I did mention that this is a particularly slow train. This is on speed step 10 and it's still very painful. This is going to take some time. It's just crossing into the finishing block now, but it does have resistive wheels on the back bogie, so I wouldn't expect this to stop and head back again until the back of the train has crossed those insulating rail joiners. Which will hopefully be shortly. There we go. And now it's going to head back in reverse. The good news, of course, is with each little journey it makes, it does get a little bit quicker. I think we're up to the lofty heights of speed step 45 now, rocketing along. So it's just passed into now the next block, and I like how it slows down. And then I think what it's doing here is it's just giving itself a bit of space before it turns back on itself, so that it's up to full speed when it passes there, which is into the block where the start and exit are actually being measured. It's just the same once it gets down here. As soon as it gets into the next block, it's effectively finished timing, so it slows the thing down and just gives itself enough room to come back. Now be at speed step 50. Obviously I'm not in control of this train in any way. This is just JMRI sending it back and forward. I'm just an interested observer. Back we go again. And that's another one done. And while it's doing all this, the little speed profiling page on JMRI is giving me information on what it's doing. This is obviously in the measuring phase, and then as soon as it hits the next block, as it's just done there, it tells me it's just waiting to clear the block. Then it's giving itself that little bit of acceleration space. Back it goes again into the measuring block. Hits the next block. And all done. After all that speed profiling is done, then what I end up with, as well as JMRI having that information to help it smoothly stop trains, it kind of gives you these tables. So I think I've done most of them now. If I view the current table for the APT, so you see they're the steps that I measured it at, and I can see, say for example, so the APT at speed step 60 would be going a forward speed of 70 miles an hour. I think JMRI can use that as well to put kind of a speedometer, so that you can set trains at scale speeds rather than speed steps. But at the moment, that's not really what I'm interested in. So for example, the super sprinter, if that's there, will probably be a lot slower. So once I got to speed step 80, it was still just at 70 miles an hour and was running at a scale speed of 5-6 miles an hour at that crawling speed step 10. Once I really started using automation, it became obvious quite quickly, I think, that I was going to need to implement signal mast logic. It just helps dispatcher and all the automation tools route trains and keep them safe, stop them when they need stopping, but it also kind of helps me understand when stuff's going wrong, why stuff went wrong, why trains stopped especially. So it's kind of set up, there's a train running around the outside line here, which is a clockwise line. In fact, it's just going to head down here now, just a 101 running around doing laps. And there is signal mast logic set up. So at the minute it's saying there that it's green for it to move into the next section because there's nothing blocking it and everything's fine. And as soon as it does and moves in, this light goes to red because obviously anything that was following it wouldn't be able to go in there. This green's for the line up there, and there's probably a caution down there somewhere as well. So once the train has cleared and gone into the next section, this light will eventually go back to green. It will miss amber out because there's one missing here for reasons which I'll go on to. But there we've gone to caution now. The one down there will be back to green again, and obviously as it makes its way around here, this one's gone to red. And similarly on the anti-clockwise line, there's nothing running around the anti-clockwise line at the moment, but there's a red, there's a danger light there, for example, and a caution light up there, then a green and a green. The reason why we've got a danger down here is because there's a set of points turned the wrong way down there. So if I find my mouse pointer and just close that set of points, you see the lights will then go to green because there's no danger, and that entire loop now is set to green because there's nothing on it and there's no obstacles or issues on it. At the moment then, all of these signals that are around the place are virtual in that they only exist on the screen, but they are configured to output light switches on and off to various points around the network through the Arduinos, the network and everything. And I do have a few test signals. So obviously there's a red, an amber and a green, and each of those would be operated by an output coming from CMRI. So in the signal heads area here, we do have, if I go and edit one of these, for example, they are set to have outputs for green, yellow and red. So as all of these values change, as a green goes to a red or a green goes to an amber up here, the outputs. JMRI is aware of the outputs that it needs to change and which node those outputs are on, so it will send the signals out to an Arduino to change the physical lights when they need changing. The physical lights are not something I've looked into yet because I want to make absolutely sure I've got stopping sensors in the right place. I think trains will need to stop at signals, so I need to work out, once I've got all the speed profiling done and got stopping sensors in underneath the track, and I have a good idea of where trains are stopping, I think the last thing I then do is add physical signals onto the layout, because it's only at that point really I'll know where to put them so that trains actually stop within a sensible, reasonable distance of the signals. Once I got going with signals, then it actually turned out to be one of the most straightforward aspects of JMRI that I've come across. JMRI is very helpful with signal mast logic, and really once you get going it kind of does most of the work for you. So I mentioned earlier that there are a couple of areas that are not covered by signals on my layout. If I just explain it, really a signal protects the next block. The way I'm working anyway with, I think you can configure them to work just with turnouts as well, but because I'm using blocks, I'm going that way. So each signal, if this is the anti-clockwise line here, this green signal here is at the end of this block and it's protecting the next block. So if there was an issue in this block or in the next one along, say if this turnout is turned against it, then immediately this signal's red. It's saying you can't go down there because there's danger, and obviously this one's turned to caution here. And once the danger's cleared, whether it was something on the track or whether it was a turnout setting correctly, then the lights go green again. And the way JMRI does this with signal mast logic is all of these signals have visibility of each other, and JMRI kind of sets them up for you. So the first thing, as I went through before, you have signal heads, and these are kind of the hardware interface really. If I go into one of these again, now this is a virtual one which I'll come on to because they're really quite handy. And here, the first ones I set up, again, they have hardware addresses, which are just like turnouts. In fact, they pretty much are turnouts. If I go into the turnouts table, even though I created these in here, and even though they're lights, they actually turn up as outputs in the turnouts table. I expect that's because signal mast logic was introduced before lights were. It would seem logical now, as signal heads are created, to put them in the lights table, but I suspect that there wasn't a lights table when signal mast logic was implemented, so it all goes into the turnouts table, which is a little bit strange, but they're all very clearly marked as signals, so you can just kind of ignore them. So once you've got your signal heads, now, yeah, one more thing with signal heads as well. I'm planning to use shift out registers for the signal, for the actual lights, and that's really quite hard to predict with all of these addresses, because I have to kind of think which shift register each light will be on which node. So I've kind of guessed with these addresses, but I expect I've got them wrong and I'll have to come in and change it, but that's okay because I can come in and change it later on. I can either create a new signal head entirely, or I can replace the hardware values on this. So I got to a point, I did, when I first set these up, I was trying to guess which hardware address each light would be on, and I'm bound to have got it wrong. So in the end, I started using virtual ones, which just don't need hardware addresses at all and mean I can worry about the hardware addresses later. Then once I've got a signal head set up, I set up a signal mast. In fact, I'll start doing that now. So what I want to do, if I come back onto this layout here, I was a bit reluctant to keep adding signal masts because I was thinking I was probably, and I may still represent each of these virtual ones with a physical one. I certainly will on the top layer. A lot of this, once the top layer's on, is going to be covered, so I'm not quite sure whether it's worth putting them on there. I'm still in two minds about it. But I was also, I was reluctant. So I've ended up with a couple of blocks, because when I split these blocks, split this one up here and this one up here and this one up here, I decided not to add signal mast logic. So actually this signal mast has visibility of this one, and which means that this block here is not governed at all by a signal mast. And JMRI
notices that and it puts it in its log. And I've found, certainly with the storage lines, I haven't even put virtual icons on for them here, but I've had to put a signal mast on every block of the storage lines because a train won't start when dispatcher is being governed by signal mast logic. A train won't start in a block that doesn't have signal mast logic, that doesn't have a signal governing the next block, protecting the next block. So I suspect I'm going to run into trouble. So I'm now at the point where I'm going to add signal masts to, I think it'll be this block. In fact, you can see which blocks are covered. If you have to click on the right click on the divider between two blocks. So this block is AC yard bypass PC end. This block is AC yard bypass pi end, and this is the divider between the two blocks. If I click on a little green icon that's not a divider between two blocks, like this one, I don't get any signal mast menus up. But if I click on one that is a divider between two blocks, I get this set signal masts. And here, because it's not protecting anything, I can see, and this is the anti-clockwise route, so the block is AC yard bypass this end, PC end, which is this end. It's protecting this one, but there is no signal mast set. So I think I'm going to run into trouble if I carry on like that. If we go, for example, for this one, now sometimes they sort of cover each other up, so I'm just trying to find an easy one that will let me demonstrate where there are signal. This one should do it. Set signal masts. Here you can see that protecting, so obviously it allows for direction for trains to run in both directions, but I this is the anti-clockwise line. They'll only run anti-clockwise, so I'm only interested in protecting this block. So that's why west northbound protected block AC PC end from junction PC end, which is this way, and then that's the name of the signal mast. So I'm going to go off and go back to my signal mast. The first thing I need to do is create a signal head. So I click add, and this is going to be another virtual one, which just means I don't have to worry about hardware addresses yet. System names are pretty awkward. You've got to enter them manually. So I'm going to H33, and now I'm going to have to remember what I need to call it. We'll do this as the anti-clockwise. We were going to go down here, so it will be yard bypass PC end. Create that. I need to do about another 4, but I'll just concentrate on this one for now and come back and do the rest. So that's my signal head created. I now need to create a signal mast for it, so I'll give it exactly the same name. This is where you get lots of options, but it's pretty straightforward really once you've selected the right things. A lot of this confusing stuff disappears. So AC yard bypass PC end. Now signal system, there's BR1, and it's the only BR1, so that's all I need to really worry about. The mast type is going to be 3 aspect, as all the others are, and the mast driver is going to be the signal head controlled mast. And this gives you all your signal heads. If you tick this and untick it, I think that's a bit of an interface bug. You get just ones that aren't currently used, and I created AC yard bypass PC end, and that's it now. All of the confusing stuff has kind of disappeared. I don't want to disable anything, and that's it. So create that mast. I now have the mast created. I can now place it on the layout. So it's going to be this block protecting this block. So again, I'll click in exactly that same place and I'll set my signal masts. So we're coming from yard bypass PC end. We're going into yard bypass pi end. We are protecting pi end because we're anti-clockwise. So I'm going to choose the mast that we just created, which is that one, and let's put it on. Let's put it on the left hand side, and done. There we go. That's going to be in a bit awkward positioning, but I'll sort that out later. It's currently across because it has no visibility of anything, and the last step to do is to kind of link it into this chain of signal masts, and I do that. This is where the really clever stuff happens. I get my signal masts back up. And again, I now need to find, let's just close this down, I don't need this for now. I need to set it in the chain that it's in, and the way I do that, if I go and find the one that I just created again, which was yard bypass PC end, and click edit logic, and if I click discover, it will go and find any other signal masts that are visible to it along this panel. So it's found the yard bypass one, which is right because it's the one to the right. And incredibly, it's done all the signal logic for me. So all of that, it's just added it in. I've never had to do anything in this table. It just knows because I've told it I want to use BR signal logic with the whole caution thing, and I've told it that where its position is on this panel in relation to other masts. It's happy now, and it'll just work. The last thing I need to do is make sure that this signal here has visibility of this one, because this is new. This one currently has, it knows it has visibility of this one, but it doesn't know anything about, you see that's gone to green now because it's worked out that it's part of the chain. But what I need to do with this one now is make sure it has visibility of this one, and effectively loses visibility. It doesn't want direct visibility of that one anymore. So this one will be ACPC end. We're still in mask, which is good. So let's edit the logic for that one. Now this one has a lot more visibility as well, because this one can see through this turnout down into here. So it can see the end blocks of the storage lines as well. I haven't put icons on for all of them because it's not really needed, but it also has this AC yard bypass visibility, which is wrong because it's cutting out the one that I've just added. So I'm going to delete this one, and I'm going to click discover again, and now it's put AC yard bypass PC end, and that's it done really. Always remember to save your work. Exit out of this, and now if I set this turnout, this new signal mast has gone to red, and this one has gone to caution, whereas previously this one was going to red and this one was going to caution because this one wasn't there. So now all I need to do is add another one there for the clockwise line, and the two up here where these blocks are split, and then I'm fully signal masted. Just a quick comparison of before and after then, using these static cameras that I'm still using to debug and work out what went on when stuff goes wrong. Currently there's class 101 making its way around somewhere. It must be under here somewhere because I can't see it anywhere else. And there's an APT coming around the incline. Now the APT is coming around this incline, and it's got these two turnouts and these sections booked. So the 101, which is down in this underpass somewhere, is going to come out of here. You can see there's caution already, and there's a red light there. So caution on the block that it's probably currently on, because it's about to poke its nose out there. And then as soon as it passes into this block, it's red. So what it's going to do, before all of the speed profiling and block length was entered, it's going to make its way out of the darkness. It's going to come, and as soon, it's under caution now, so it's running slowly. As soon as it enters the block that's red, it stops. That's danger. So even though kind of the signal and the end of the danger block is up here, it's stopped down here, and that's because the length of the block is the default, which is 0 in JMRI, and also JMRI doesn't know how fast the train's going, so it can't calculate a slowdown. So in the interest of safety, to make sure it doesn't head out of the block into the next block that's danger, as soon as it knows that the train has entered this block, it stopped it. Now for the after then, slightly different in that the APT is at the start of its journey, so it's got the route onto the incline blocked, but it's still having the effect of the 101, which again is under here somewhere, having to come to a stop. So we're in the same situation. We've got caution light on this block here, and although it's covered up, there's a danger light on this block here. So if I play it on this time, 101 should magically appear again through this gap, and it will be running at caution like it was last time. Here it is. So it's already at caution. It
moves into this next block now, but this time JMRI knows how long the block is, and it has a speed profile set up for the 101, so the 101 just rolls to a nice gradual halt within this block. I think for more precision I might at some point put stopping sensors in as well, right? You're very close to the end of the block, just so that there's a more precise stopping point, which would mean I could put a signal here. But I still, I feel like I'm getting there with the train slowing down nicely now. Now the APT's out of the way and heading up the incline. The 101 sets off again and will be visible, I guess, down here. And that all seems very calm and serene compared to how it was when I started this thing.